champions, welcome to the channel, and in today's video we are going to solve the last 10 years of COMEDK PYQs of a very important physical chemistry chapter, that is chemical kinetics. So I have completed all other chapters of class 12, so this is the last chapter of class 12, so please revise this chapter thoroughly and then watch this video and solve the PYQs. Now before moving ahead, let's understand the weightage of this chapter. So if you see from last 3 years, that is 23, 24 and 25, chemical kinetics, you are getting 4 questions every year. Okay, so definitely it is a high weightage chapter, so please prepare it thoroughly. Let's see the first question here and understand the level of the question. What fraction of a reactant remains after 40 minutes or if the T half is 20 minutes for a first order reaction? Okay, now suppose you are starting with fraction, it is asking, so always you have to start with 1. So after after one half life, means after 20 minutes it will become half. Then after second half life, that is total 40 minutes, it will again become half of this one, that is 1/4 here, right? So that is option number A. Okay, what fraction of the reactant remains? Okay, yeah, so 1/4 will remain here. Clear? Next, question number 2. For a reaction A to B gives you P. If the B is doubled at constant A, the rate of the reaction doubles. If you are doubling B, rate also doubles. So first let us write the value of the rate expression. It is K into A to the power of X and B to the power of Y. Now from the first line, that if B is doubled at constant A, the rate of the reaction doubles. That means Y value is equal to 1. Now if A is tripled and B is doubled, you have taken A is tripled and B is doubled. Okay, the rate of the reaction increases by a factor of 6. Okay, now we know that Y value is 1 and this becomes 6 times of R. That means what should be value of here? This one should also be 1 here. Okay, then only if you have here also 1 and here also 1, then I will get 3 into A into 2 into B, and that will give me 6 times of A into B. Right, so that is when the rate will become 6 times. So what is the overall order of the reaction? It is 2. So the correct answer for this question will be option number D. Okay, I hope this is clear. If it is B is double, the rate is becoming also double. That means with respect to B, it is first order. Then when A is tripled and B is double, for the rate is becoming by a factor of 6. So from here it will become 2, and for making it 6, this also should become 3. Means when you are increasing the concentration by 3 times, the rate also increases by 3 times. So that means both are first order and the total overall order of the reaction will be 2 here. Now let's move to the next question, but before that, so students, if you have written KCET 2026 examination and want to predict your rank, then me and my team has prepared a very useful tool for you, for all of you. So what you have to do here is to enter your PCM marks, and you also have to enter your KCET score out of 180, and then just click on predict rank. So once you click on the predict rank, here you can see your estimated rank. Okay, and you will also be seeing the range between which your rank may fall. Okay, more likely to fall. Now this will also show you the total your aggregated percentage, like 50% from KCET and 50% from your board exams, how much you are getting, that it will show. And if you scroll down, you can also see the colleges and branches that is more likely that you can get based on your rank, and this is based on the cutoff of the last year. Okay, so this will definitely help you to understand the different courses, different colleges, different options available for you, and now you can prepare yourself for the counseling process. Okay, so the link of this tool will be there in the description section. You can check this out. And now let's move to the next question. The question is, the rate constant for a first order reaction is 7 into 10 to the power of -4 second inverse. If the initial concentration of the reactant is 0.08, the concentration that will remain after 35 minutes is. Okay, so this is very simple direct question on the rate law equation. So we have K equal to 2.303 by T log of A naught by A. Right, this is the equation. Now if I have this formula, I have to calculate the concentration that will remain after 35 minutes. So K value is 7 into 10 to the power of -4, and this side it is 2.303, time is 35 minutes, log of this one is one second, this one is 0.08. So I can write it as 8 into 10 to the power of -2. Okay, divided by x. So I have to find this x value. Now this is 35 minutes and we must convert it into seconds because this is in seconds. So I will multiply here 60. So I have now 7 into 35 into 10 to the power of -4 into 60. Okay, this is second and this is second inverse, that will get cancelled, divided by 2.303 is equal to log of 8 into 10 to the power of minus 2, okay, minus log of x. Okay, this value we have got. Now I can find the, so let's first solve this part, then we'll subtract. But in COMEDK you have calculators, you can easily do this calculation, you don't have to worry. Okay, so now if I see this is 2.3, I can just assume it as 2.1 for easy calculation. So that will become 7.3 is 2.1. Okay, I have done this to make the calculation simple. And 3.1 and 320, so that gives me here 35 into 2 is 70, right? And I have one decimal place here, and this is 10 to the power of minus 1, it goes up, so I will have 10 to the power of minus 3. So that gives me here around 0.7 on the left hand side. Now that is equal to log of 8 into 10 to the power of minus 2. Now you know that log 8 can be written as 2 to the power of 3 or 3 log 2, and 3 log 2 is 3 into log 2, that is equal to 3 into 0.301. That gives me 3 ones are 3.903. Okay, so I have 0.903 minus 2 here. Okay, so that will give me I can subtract here 2.000.903, so that gives me 0.1097, right? Yes, so minus 0.1097 minus log of x. Okay, now you can take this log x to this side, so log x will be equal to minus 1.097 minus 0.7, right? This goes up, so this gives me minus 0.797. Okay, now what I can do here is, this is log of x. Now x will be equal to what? 10 to the power of minus 1.797, right? That can be written as 10 to the power of minus 2 plus, sorry, 10 to the power of minus 2 into 10 to the power of, so I'll just subtract 2.000 1.797. So 10 minus 7 is 3, 9 minus 0, 9 minus 7, 2. Then I have, 1 second, yeah, 10, yeah, log of 0.203. So now we have to find a number whose log value is 0.203, right? Now we know that log 2 will be 0.301. So this one, this number should be somewhere around less than 1, like less than 2. Okay, so let's assume that it is log 1.5, for example. Okay, log 1.5 or log 1 point something, 1.5 suppose. Then 10 to the power of minus 2 will be somewhere equal 0.01 something, right? We don't know this number exactly, but we know that it has to be 0.01 something. So that means your answer will be option number D here. Okay. Next, question number 4. The rate constant K of a reaction is dependent on the temperature, as this is K has the least value at. So when we have a higher rate of reaction, for that we need higher temperature and lower activation energy. So that is option number D here. Next, which of the following graphs will show the variation of partial pressure of N2O5 decomposing into NO2 and O2 following the first order kinetics? Now in the first order kinetics, what happens? The reactant concentration decreases in an exponential order, right? So that is why correct answer will be option number C here. Next, for the decomposition of compound AB at 600 Kelvin, the data is given. The order of decomposition of AB is. Now see, when you have doubled this concentration, okay, 2 to 4, you have doubled the concentration. This has actually become 4 times, right? If you see 2.75 into 4 will give you 11. So that means when I'm doubling the concentration, the rate is becoming 4 times. That means it is a second order reaction. So answer will be option number C here. Next, in a zero order reaction, for every 10-degree rise of the temperature, the rate is doubled. Now, if the temperature increased from 10 to 100 degrees Celsius, the rate of the reaction is 10 to 100 you are going, right? So 10 to 20, 30, 40, 50, 60, 70, 80, 90, 100. So it is almost like 2 to the power of 9. So 2 to the power of 9 will be 2 to the 4, 4 to the 8, 16, 32, 64. Then you have 128, 256, and then you have 512. That is option number B here. Now let's see question number 8. In a first order reaction, it is 20% completed in 500 seconds. And how long it would take for the reaction to go 60% completion? Now remember, time is proportional to log of the remaining amount. Okay, so now if I see for 500 seconds, that is equal to log of 1 by, see, 20% is completed, 80% is remaining, or I can say 0.8, or that is equal to 500 is equal to log of 8 I can say 1.25. Okay. Next one we have t is equal to log of 1 by 60% is completed, 40% is remaining, so 1 by 0.4, and that gives me t equal to log of 2.5. Okay, now what we have to do, we have to solve this. Okay, so we have now, see, 500 divided by t is equal to log of 1.25 divided by log of 2.5. Okay, now we can solve this. We know that these are both multiples of 5, so for 125 I can write as 1.25 can be written as, see, log 1.25 can be written as log of 125 into 10 to the power of minus 2. Okay, and log 5 is around 0.698, so we'll have log of 5 to the power of 3 plus log of 10 to the power of minus 2. So it will be 3 log 5 plus minus 2. Now 3 log 5 will be 3 into 0.698, 3 into 0.698 minus 2. So that gives me 3 are 24, 29, 20. So I'll have 0.2094 minus 2, that will be around 0.094. Okay, now we have this side log of 2.5. Okay, log of 2.5 will be equal to log of 25 into 10 to the power of minus 1. Okay, that gives me log of 5 square plus log of 10 to the power of minus 1. Now 2 log 5 is 2 into 0.698 minus 1. So that gives 2 8s are 16, 2 9s 18 plus 1 19, 12, 1.396 minus 1, that gives me 0.396. Okay, so now if I solve this, so that will be you can see 0.698, so log of 1.25 and we have log of 2.5, so log of 1.25 value will be around how much, this one I have calculated here, 0.094, and this side I have 0.396. Now what is the value of time then? Time will be equal to 500 into 0.396, okay, divided by 0.094. Now if you divide this, you will get like 4 4s are 16, 4 9s are 36 plus 1 37, so almost 4 point something you will get. So it will, if you calculate, you will get 4.1 nearly. And now if I multiply this with 500, 5 ones are 5, 5 fours are 20, and have two decimals, one I'll put here, so 2050 will be the correct answer. So the nearest option will be option number A here. Next, the temperature dependence of the rate constant K is expressed as K equal to A into minus EA by RT. When a plot between the log K and 1 by T is plotted, what is the value of the slope? So the value of the slope here, you can see it is minus EA by 2.303 R. So you have this equation K equal to A into e to the power of minus EA by RT. Okay, now if I take ln of this equation, that will give me ln K is equal to ln A minus EA by RT. Now if I want to convert it into log, so that will give me 2.303 log of K is equal to 2.303 log of A minus EA by RT. Now divide 2.303 throughout the equation, so we'll get log K is equal to log A minus EA by 2.303 RT. Okay, so if you see the equation, this is y equal to m, x and c, right? So the equation of the slope is minus, slope of this equation is minus EA by 2.303 R. You should remember this, you should not derive it, okay? Now consider the reaction P2Q here. The concentration of both the reactants and the products varies exponentially. Which of the following figures correctly describes the change in concentration of reactants and products? So P is the reactant, its concentration should decrease, right? So you can see here P is decreasing, here also P is decreasing, here P is increasing, here P is decreasing. So these three equations are correct. Now Q is the product, so Q concentration should increase. Okay, here Q is increasing, here also Q is increasing, here also Q is increasing. But here you can see there's a linear equation, but that doesn't happen, so this is also incorrect. Now Q, when the product concentration increases, it first increases exponentially and then decreases. Okay, it is not slower at the starting, it is very fast at the starting. So that is why this equation, the slope at the initial time should be higher. So B is the correct answer. Next, for the reaction 2NO plus H2 gives you N2 plus 2H2, the possible mechanism is. So what is the rate law and the order? See, the slower step always determines the rate law. So here N2O2 and H2 is there. So rate will be equal to N2O2 and H2 and the order will be 2. So the correct answer will be option number B here. Now moving to the next question, the energies of the activation for the forward and reverse reaction are given. So I'll draw a energy diagram here. Okay, so we have here A2, B2 to AB. Okay, see it is like this. A2 plus B2 and I have AB here. Okay, the energies of activation of the forward and the reverse are 180 and 200 joules. So this value is 180 and we have this value as 200. Okay, a catalyst lowers the activation energy by 100 joules. So this is lowered by 100 joules. Okay, so now already it was 180. So now this one is 80 joules. Okay, 80 joules, and this 200 will now be reduced. So this one is now 100. Okay, this one, this one is 100. The backward activation energy now is 100 and the forward activation energy now is 80. So what is the difference or what is the energy between these two? That is 20, option number A here. Next we have two plots are shown below between the concentration time t. Which of the following orders are shown by the graph respectively? So okay, this here we have already mentioned by mistakenly. So actually you can see this is actually 0th order. Okay, this, please don't check this one. Okay, this is printed misprinted, so you have to just see the graph here. Okay, so this is a like concentration versus time, it is decreasing linearly. This is the graph for the 0th order, and when you have 1 by a minus x, this is the graph for the second order. So it is 0 and second order, so option number C here. If log term is there, then it will be first order. Next, in the reaction 2x gives you why the concentration of x decreases from 0.5 to 0.38 in 10 minutes. What is the rate of the reaction? So this is very simple calculation. Rate of the reaction is equal to change in concentration by time. So we have, if I change the concentration, it is 0.5 to 0.38 divided by 10. Okay, in seconds. So I have to multiply 60 also. So I have 10 minus 8 to 0.12 divided by I have 6 into 10 to the power of 2. Now this goes up. So I will have 0.02 into 10 to the power of minus 2 and can be written as 2 into 10 to the power of minus 4. Option number A here. Next, for the reaction 2NH3 gives you N2 plus 3H2. If dNH3 by dt is this much, dN2 by dt is this much, dH2 by dt is this much, then what is the relation between K1, K2 and K3? Now if I write the differential rate equation, rate is equal to minus 1 by 2 of dNH3 by dt, right? That is equal to plus dN2 by dt, dN2 by dt, and that is equal to plus 1 by 3 of dH2 by dt. Okay, now we have minus 1 by 2 of K1, dNH3 by dt is equal to K1 NH3, that is equal to K2 NH3. Okay, and this is equal to K3 NH3. Right, this value I'm writing. Now what is there is here 1 by 3 is also there. Now you can see that there's no such NH3 will get cancelled from all of them. So I have K1 by 2 is equal to K2 is equal to 1 by 3 of K3. Now there is no such relation, but if I multiply 3 to the whole equation, then what I will get? I'll get 1.5 K1 is equal to 3 K2 is equal to K3. So that is your option number C here. Next question, during the kinetic study 2a plus b with the data, which rate law is correct? So let us assume that rate is equal to k into a to the power of x and b to the power of y. Now first we will check keeping b constant. Okay, so b is constant in these two equations. Now what we have done to a, we have doubled, like we have made it 4 times, and here this one also became 4 times, right? So that means x is equal to 1. Now with respect to y, if I want to calculate y, so a should be kept constant, these two will be constant. So here when I'm doubling it, this one will become 4 times, right? So when I'm doubling the concentration of B, the rate is becoming 4 times. So that means y is equal to 2. So the overall order or the rate law will be Ka B², option number D here. Next, what will be the rate equation for the reaction 2x plus y gives you z if the order of the reaction is 0. If the order of the reaction is 0, then rate will be equal to K only. Okay. Next, if the rate of the equation for a reaction is given, then the order of the reaction is, order will be the overall order. So with respect to 1, A it is 1, and with respect to B it is half. So that gives me 3 by 2 or 1.5. So C here. Next, an endothermic reaction with high activation energy for the forward reaction is given by. Endothermic reaction means energy of the product should be higher. Here it is lower. This is incorrect. This is also incorrect. Now here energy of the product is higher. Here also energy of the product is higher. Now the question is asking with a higher activation energy. Here this activation energy is very high for the forward reaction. But if you see here, this activation energy is less. So that is why option number C here. Next, the reaction is given as 2P plus Q gives you product. If the concentration of Q is kept constant, then the concentration of P is doubled, then the rate of the reaction is. So if you see there's nothing is mentioned regarding the order, then you can write it like this. Now when 2P it becomes, okay, that will be 4P square, okay, and this will be equal to R is equal to 4 times of rate. So it will become quadrupled, option number C here. Next, 3A gives you 2B, the rate of the reaction dB by dt is equal to. So here we have rate is equal to, I can write the equation as minus 1 by 3 of dA by dt is equal to plus 1 by 2 of dB by dt. Okay. Now, if you see here, dB by dt will be equal to 2 by 3 of dA by dt, which is option number B here. Next, 90% of a first order reaction is completed in 70 minutes. The velocity constant. So velocity constant is nothing but to calculate the rate constant. So you will have 2.303 by T. T is how much? 70 log of 100. 90% completed means 10 is remaining. So that means log 10 is 1. So I have this one, 70 minutes. Okay. So I have to just divide this 2.2. So I can write 2303 into 10 to the power of minus 3. Okay, and I'm just dividing this with 70. Okay, so 73 obviously will be 210, so that will give me 203. Now I'll take here 1 second. Yeah, so that will give me 210. So I'll get this value. Next I have 3. So I will take this time 3 sevens are 23. Sorry, 2 I'll take this time. So I'll get here 2 zeros are 0, 2 sevens are 14. So I'll get here 63. Then we have one more decimal I'll put here. That will give me 7 nines, right? 329 obviously into 10 to the power of minus 3 will give me 0.0329, which is option number A here. Next, this reaction is given. This is the ester hydrolysis in the acidic medium. So that is a pseudo first order reaction. So option number A. How enzymes increase the rate of the reaction? By decreasing the or lowering the activation energy. For the reaction X to Y, the graph of the product concentration X versus time came out to be a straight line passing through the origin. Okay, the graph of the product concentration means A. Okay, product concentration versus time came out to be a straight line passing through the origin. Now, hence the graph of minus dx by dt and the time would be. Now, this you can see if it is a straight line, it is definitely a zero order reaction. Okay, and for zeroth order reaction, if you are talking about the concentration versus time, it is a straight line passing through the x-axis. In a chemical reaction, A plus 2B gives you product. When the concentration of A is double, the rate increases 4 times. That means with respect to A. So first if I write AXBY, okay, so when the concentration of A is double, the rate increases 4 times. So that gives me the value of X is equal to 2. Now when concentration of B alone is double, the rate continues to be same. That means Y is equal to 0. The order of the reaction will be 2 here. Now let's see question number 27. The rate of a chemical reaction doubles for every 10-degree rise in temperature. If the temperature increases by 60 degree, the rate of the reaction would be. Now from 0 to 60 degree, if you say it is increasing 6 times. So like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So it will be 2 to the power of 6, which is 64 times, option number C here. Next, an endothermic reaction A to B has an activation energy of X. Okay, so now we have a reaction like this, A to B. Okay, this is an endothermic reaction having an activation energy of X. Okay, now if the energy change of the reaction is Y, this is the energy change. Then the activation energy of the reverse reaction, then this will be X minus Y, that is option number B here. Next, AP plus BQ gives you product. When P is doubled, keeping Q constant, the rate increases by 2 times. Okay, P is doubled and rate is also doubled. So I'll first write the equation. Let it be like this: P to the power of X and Q to the power of Y. Now, if the P is doubled, keeping Q constant, then rate also increases 2 times. That means X value is equal to 1. Now, when P is constant and Q is doubled, the rate increases 4 times. That means with respect to Q, it is a second order reaction. The overall order will be 3. So, option number 3 here. For a reaction between A to B, the order with respect to A is 2 and the order with respect to B is 3. Okay, so I'll just write down here. Order with respect to A is 2 and the order with respect to B is 3. Now the concentration of both A and B are double. So that means this will become 2A and this will become 2B. Okay. So now if I see 2 to the 2 to the 4 to the 8 and 8 into 4, 32. 32 into K into A square and B Q. Okay, so the rate has increased by a factor of 32, option number C here. Okay, students, these are the most important PYQs of last 10 years. So please solve it and just understand the exam pattern. And the KCET rank predictor link is there in the description section. You can definitely check it out. Thank you so much for watching and all the best, and stay tuned for the next chapter.